Hey everybody, this is Larry. This is me coming Q3 of the bi-weekly contest 143, maximum frequency of an element after performing operations 2. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about this one. So this one is a harder version of Q2, and even the live portion I actually put in the Q2 video. I didn't want to redo Q3 here. So definitely check that out. A lot of the art is going to be overlapping. The only thing that's different between this one and actually let me open Q2 real quick. The only difference between Q2 and Q3 is the range of numbers, 10 to the 9, and I guess K as a result. But that, I mean, I guess that's different. But you know, but yeah. And the way that I thought about this is the same that I thought about in Q2, right? So in Q2, we call and if you want to go deeper, definitely watch that video. We just go from the smallest number to the largest number. And the reason why we don't go smaller than the smallest number is because to the left of it, it doesn't make sense, right? And what I mean by it doesn't make sense, actually let me bring up the drawing board. Maybe I should have started with the one. The reason why it doesn't make sense for, and this is, let me start over. The reason why it doesn't make, sorry friends, let me actually spend time to set up so I don't keep on saying sorry friends. But yeah, so we have a number line, right? And let's say your smallest number is x0 is here, right? Well, it doesn't make sense to choose a number that's smaller than here, because that means that even this, like a very trivial better answer is just this number. Oops, I can't draw a line quick. Like this line is always going to be better than this line, right? Just because you have one overlap. So at worst it'll be the same in the number of things, but it'll be one fewer operation. So it'll always give you at worst the same answer with a fewer operation, right? Okay, and of course for symmetry reason, the same for the max. I'm not gonna get into that deeply. So that's kind of the one key observation. The second thing, so for this particular problem for Q3, the thing that I noticed, and here you can maybe notice that the live portion of this is really quick. I actually only did it in like 3 minutes. Because I kind of saw the proof. I kind of halfway saw it when I was doing Q2, but I wanted to make sure that I got the quote-unquote dumber solution down so that I can at least test against it, and also just to, you know, nail in something, I suppose. But yeah, so the idea here is that, okay, well, it's just trying to find these critical points, right? So in Q2, we basically test every number on the number line, right? Which is the smallest number. Well, I guess we reduced it to the smallest number to the biggest number, right? So we did reduce it there, right? That's fine, but this range can be very big for Q3. So then the idea here is that, okay, well, now what I was trying to do is just try to figure out what are the critical points. And it turns out with this particular problem, you can kind of reduce this to just using I mean, there are probably better, stricter proofs, but I think you can actually do a case analysis on two things, and it'll kind of get you the idea, right? And the idea here is that, okay, x sub 1, well, let's say you only consider these two elements, there are really only two cases, right? Or three cases or whatever. One is at x0, the other one is at x1, right? So obviously, and yeah, and whether whichever one makes sense, it actually doesn't even matter that much with respect to these two. It just depends on the size of k, right? Like it depends on what k is and whether they overlap, right? So then, and the other thing is that, okay, well, here you want to try a number that's in the middle, but it doesn't even have to be at exactly the middle, though I think you can actually do it that way. Maybe not, I don't know. But the way that I came up with this idea is through the similar thing about sliding window, right? I didn't implement it using sliding window, but if you think about it with sliding window, there are only events that happens at, like, where the events that happen. Well, events happen, let me change the color real quick. Events happen here and here, right? That means that when we're trying to figure out like the maximum overlap, the only thing that changes are from here, the left endpoints and the right endpoints, right? Because everything in between is always going to be the same, and that's really the way that and that's really it, honestly. I just kind of noticed that these are critical points, and of course there are probably better proofs and things for better bounds, but for this problem I did not need to. Oh, this is Q2, whoops. For Q3, that's basically the idea. Yeah, so here, this is my Q2, you can see that I go from the range smallest to the largest. For Q3, this code is exactly the same, we just test different numbers with X, right? And here, as I said, I only care about the events. I have yeah, we still have to sort nums, so that could have been a mistake. But the, the events are that we're right on top of X, where the smallest K or the largest K, or largest X plus K or X minus K. And we just have to test all of them. We sort all of them, and then we calculate them, and that's pretty much it. Because the answer only changes at these horizons, right? And actually, you don't even need to sort events. I think I just sorted because that's the way that I think about it with sweepline, but you actually didn't even need to sort this because you're just testing this, right? You just you have to make sure you sort nums, but events you do not have to. But yeah, and you can also, if you did it with sliding window, I think you can also just keep doing it with the sliding window as long as you do it the sliding window in a clean way. But I think this for me, binary search was easier to write and fewer ways of making mistakes, just because I'm practiced this way, right? And that's pretty much it. Like I said, this is going to get you all the numbers in a range. We just have to figure out the numbers we care about, which for this one is X for right on a number, X minus K, X plus K. It's just for the case where you have two numbers and they meet in the middle somewhere, right? And that's pretty much it. What is the complexity here, right? Well, the number of events is going to be n log n. Well, this is going to be n log n anyway. So yeah. So this sorting is going to be, well, this sorting is going to be n log n, but this for loop is O of n after the sorting. And of course, this is just log n for two operations, two log n operations. So this is the entire thing. It is just O of n log n. Regardless of the numbers. So yeah, you could do a little bit better with sliding windows, but again, this one is not even necessary because it doesn't, you still, like, it still gets dominated by the sorting, though in practice it'll be a little bit faster. But yeah, or maybe a lot faster. I don't know how much faster Leetcode is on this one, but that is the idea behind this. But yeah, that's all I have with this one. Let me know what you think. Thanks for watching, and yeah, you can watch me solve it live. But only the second part, so if you want the full self, watch the Q2 video. It's kind of a little bit mangled, so I don't know. But yeah, you can watch that now. Alright. Okay, does this work for, this isn't, oh no. I was gonna say, does this work for Q3, but I don't think so. Well, definitely not. This is on this range, right? Can we reduce it? We can reduce it by sliding window. Right. The only thing that, so it only changes on, so I'm looking at Q3, but the only thing that changes is that we cannot, nums of I is a lot different, right? So this, so I'm going to do it on Q2 and change it so that we don't base on this. And I think the thing is that, okay, so num sort events is equal to, well, maybe something like, no. So number, you gotta change it or you don't. I want to say something like, how many people got this one yet? 16? Oops. This is right. I want to say this is right. It's a freebie, I think. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this prompt, this contest, everything in between. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.